Hello, welcome to Maine Electrical Institute's video series on Basic Electricity 1. In this series, we're going to help the student who perhaps missed a night in our classroom and needs to get caught up, or maybe you're a student who's enrolled online or correspondence and you're working through your books and you're struggling through some concepts, or you just want to use these videos to help further aid you in your understanding. That's what these video series are intended for, and so we hope that they'll be helpful. Again, this is the first in the series called Basic Electricity 1, and we are going to progress through all of the material needed in a systematic manner by topic so that you'll be able to find everything that you need in an orderly fashion. So first of all, we're here today to begin the series, and what we want to do is actually ask a very simple question. It's the question, what exactly is electricity? What is electricity? I've asked that question a lot to many students, and I get some humorous efforts to define it. One of my favorites is electricity is magic. That's always been one of my favorites. But what we'll find in this class is that electricity is anything but magic. We can understand, we can define, we can depend on electricity to do certain things because electricity follows the laws of physics. And so by the time that we're done in the next several sessions, you'll be able to understand what electricity is, and you'll rule magic off of your possibilities. So what is magic? What is electricity? Electricity, in its most simple form or simple definition, is, and I'm going to share with you a very simple definition. We're going to have to build on it. It's not an entire definition, but it's a beginning point that we can start to build on. So bear with me, but this will be the definition that we start with. Electricity is simply the movement of electrons, okay? So in its most simple definition that we're going to start with, electricity is the movement of electrons. The problem with any definition is that if you use words in the definition that may not be known, then you have to define those. Well, I'm going to assume that somebody watching this might not have a good handle on what exactly are electrons. All right, it's great. Electricity is the movement of electrons. But what exactly are electrons? Well, in order to understand what electrons are, we need to go back to the atomic structure. What is an atom? An atom is the smallest building block of any element that still retains the properties of that element. Now, if you go to your table of elements, you'll see that there's a whole bunch there, and each one of those elements has a slightly different signature, they're built differently. That's what makes them unique. Well, every single one of them are common in this way. They all have neutrons, protons, and electrons. Neutrons, let me draw this out. So I'm going to use purple for protons. Makes sense? Let's say we have 2 protons. Okay? And then we'll make blue neutrons. The neutrons and the protons, they cluster together and they form what is called the nucleus of an atom. Now, every element is different. Hydrogen only has 1 neutron, 1 proton. And then as you progress on through the table of elements, as the elements get heavier and heavier, they begin to collect more neutrons and protons. And it's those things, it's these parts of an atom that actually define what an element is. Each element, it's like a fingerprint. If there's two elements that have exactly the same structure, it's not two separate elements, it's the same element. There are no two elements that have identical atomic structures. If they did, they wouldn't be two separate atomic structures, they'd be the same type of element. Well, this makes up the nucleus, okay? And the nucleus is what goes around the nucleus are another part of an atomic structure called the electron. Okay? So electrons, they orbit around the nucleus like the moon orbits around the Earth, or the sun orbits, the Earth orbits around the sun. I know that the sun doesn't orbit around the Earth. So here is an example of an atomic structure. I'm not a chemist, so I don't actually know which element I may have just created. I don't even know if that is an element. So if you're a chemist watching this, forgive me. I'm not sure that I just created something accurate. For the purpose of this illustration, I want you to know that neutrons and protons, they are clustered together and they form the nucleus of every atom. Now, how many neutrons and how many protons? That depends on what you're talking about. Is it iron? Is it silver? Is it coal? Whatever element we're looking at, that would be different depending on what element it is. And how many electrons there are. And not only that, but there can be a variety of orbits. These electrons, they go around, they float around, and depending on which element it is, there may be one orbit with one electron. There might be two orbits with 3 or 4 or 5 electrons sharing on those orbits. Or there might be 4 orbits with 16 or more electrons floating around. And so when we say that that electricity is the movement of electrons, what we're talking about is when an electron can be removed from one atom and flung onto another atom, so to speak. Now, if you stay with me through these series, we're going to build upon these concepts. You'll be able to understand electricity very thoroughly. If you just watch any one individual segment, what I say may confuse you. So I'd encourage you to watch the videos in context, the surrounding videos. They're built in a series. They'll be numbered, but then they'll be topically titled so that you can find things topically, but you should know where to go to get to the one before it and the one after it, and hopefully things will make sense the more you watch the surrounding videos as well. So in this episode, or this session, we're going to discuss what is electricity. Well, electricity is the movement of electrons. Well, electrons are not, well, let me put it this way. Atoms do not, we draw them flat on a dry erase board. But what you need to know is that each orbit, this orbit might be going this direction. This orbit actually might be coming 90 degrees off and coming this way. The other orbit might be going at a 45-degree angle this way. And that's important that you understand that, because what actually happens, the more electrons there are, the more orbits there are, as these electrons start to flow around in multiple different directions depending on which orbit they're in. And one's going this way and one's going this way and another one's going this way. So you got this multi-directional orbiting going on with various amounts of electrons flowing around. what ends up happening is it actually forms a shell around the nucleus. These orbits actually form a shell. It's kind of like, have you ever tried, don't try this at home, but have you ever done it? Have you ever tried to stick your finger in between the blades of a fan that's moving? Not a good plan. However, if you've tried it, you know there is technically space between those blades. So are you ninja enough that you can stick your finger in there and pull it out again before you get touched? Well, of course not. You put your finger in there and you're going to get clipped. Well, even though there's technically space between those fan blades, the fan blades are turning so fast that they effectively create a shield or a shell. Well, that's actually what takes place here. We're not talking about random floating lazy electrons. These things are spinning very, very fast, and they're spinning in different directions, so much so that they create a shell. Now, first of all, let's just make sure we understand that when we say that electricity is the movement of electrons, we're not saying the movement of an electron around its orbit. That would just be orbital movement. Electricity is when an electron can be bumped, as I said, or flicked or flung from this atom to, let's say there was another atom right here, that an electron could be bumped and transferred onto this atom. That transfer that would be there would be electricity. It's that movement of electrons that we're talking about. So I want to make sure that we understand too that each of these elements have a particular charge. I'll write it down here that protons have a positive, well, that wouldn't work. Protons have a positive charge, okay? And neutrons, they don't have a charge. They're neutral, okay? And then electrons, they have a negative, okay? So it's important that we understand that protons have a positive charge, neutrons have a neutral charge, and electrons have a negative charge. And it is the electron, by the way, which actually is the active part of electricity. Protons and neutrons stay together in the nucleus. But the electrons, they can move between atoms, and that is what creates electricity. We're going to talk a lot more about how and why and when and what can we do to manipulate that. But the basic idea is that that electricity is when one electron can bump off of its original atom onto another atom, and then that is called electricity. Remember that electrons are negatively charged, protons are positively charged, and neutrons are neutral charged. Okay, we're going to stop here, but I encourage you to continue to watch because we're going to build on this principle of what is electricity. We're going to start to answer the question, what exactly causes an electron to bump off of one atom and onto another, and how does all that work? So stay tuned, come back to the next episode, and let's keep working through these concepts. Thanks for watching, and we'll see you soon.